Hi, I'm Neil, and what I want to do today is talking about light and how we might teach light to primary age students. And the equipment I'm going to use as a plant, I'm going to use a mirror, I have a cardboard eye, and possibly most important of all, a cardboard box. And fundamentally, before we start, we need to understand what the misconceptions are about light. And a couple of things is students have a tendency to think that light comes out of their eyes and somehow illuminates things. And how might we get around that problem to start with? Well, if I just switch my light off, I suddenly go darker. And I switch the light on, I'm much brighter. And the question is, well, why? Why does that happen? And one of the reasons for that is that light is coming from the light which is behind my phone at the moment, bouncing off me and then going back to you. But we could talk about reflection, but part of the problems with reflection, particularly with younger students, is reflection means mirrors. So we look at a reflection and we're looking at 100% reflections. In maths, they'll often be asked to do reflections in maths, and a reflection on the x-axis or y-axis, etc. in maths, and that's an exact copy of the original. So this whole idea of partial reflection, which is what we're trying to get across, is quite difficult. We have to be careful of the language we use when we're doing this. So I'll start with a question. I have a plant here, you can see it's green. The question is, can it grow in green light? And if I've got a class, I would say, right, put up your left hand if you think it grows better in green light. Put up your right hand if you think it doesn't grow as well in green light. And put up both your hands if you think it makes no difference. And then keeping your hands up, find someone who disagrees with you and go and listen to them and think, do they have a point? Do they know something I don't? Can I learn something from this? Don't just try and argue your point of view. Try and actually listen very carefully to others and see if you can come up with a consensus. So there's the first question, but in order to understand that, we have to understand what light actually is and how it's reflected. Now, what light is something which is incredibly complex. Sometimes it behaves like a wave, sometimes it behaves like a particle. We don't have a model in our head that kind of works for light, but we do know a few things about it. We know that there are certain things which emit light. So for example, I have a torch here, which is emitting light. The sun is also a light emitter. I can look at different types of lights as ultraviolet. If you want teeth whitening, don't spend a fortune on it, just get yourself an ultraviolet light and hold it in front of you. Question, why does that happen? Why does something which is blue glow white? And I'm not looking for all the answers at the moment. Sometimes I'm just putting questions into the heads. I'm sowing seeds. I don't think we always need to know the answers. I think what we need to do is to create curiosity, to create knowledge gaps, things that leave the students thinking in more detail. So I haven't told you the answer to this yet, the green light one, and I'm going to leave that for a little bit later because you can come up with your own conclusions. So when we're looking at light, how might I teach about light as being something that we see that's coming into our eye? Well, one of the best things to use is just to get a big model like this, and you can actually see that light, we could actually see there's a hole in the middle here, which is a pupil, and light is actually entering this hole. So how does something that's red, for example, why does that appear red? And have a little thought, think about that first, because what we actually have is we've got white light coming from my light here, it's hitting the red, and it's going back to you as red. And what I use for this one is use a table tennis ball. So at the moment, the white light is actually coming from behind the phone here. It's hitting the red. Now everything, all the other colours in the light are being absorbed, and the only thing being reflected is the red light. Hence, it appears red. And this is where I'll be using my model. If I'm going to have a class, what I'm actually saying is that when things are being reflected, so I've got the reflection of, supposing it's being reflected, of red lights being reflected, as it's being reflected, some of it hits the edges of our eyes, but some of it will go directly in, and we will perceive that as red light. One of the key questions as well about light is does it travel in straight lines? This should be fairly apparent because obviously we've got shadows, but one of the things I can do is I can just go, well, you can't see my face now, but you can still hear my voice. Why? And try and elicit from them some responses of why they think that might happen. Now, what's clear about this is that light can't travel in curves, otherwise you would be able to see my face and the light would be able to be coming from my face, whizzing around and going into your eye. But you can't see that, but sound has that ability. And certainly at the younger ages, I'm not interested in them coming up with an answer. The key thing I want from them is the fact there's a fundamental difference between light and sound and the way it travels. We don't need to understand why or how at the moment. We just need to realize there is this fundamental difference. Another thing about light is please don't call it light energy. Because when we actually come to do energy, if you're working in the UK curriculum, light is not considered to be a form of energy. Energy's forms has actually disappeared, and we talk about energy stores. And light is not an energy type. Light is a transfer mechanism. So if I were to shine this light and then switch it off, where's the light gone? What's happened to it? It's a transient phenomenon, and basically the thing with light is what it's done is it's actually gone out and it's interacted with other bodies, and the universe is now slightly warmer than it was before the light was actually emitted. So light is a transfer mechanism. It's not a type of energy. It's measured in watts, not in joules. Just a minor point, might seem a minor point, but certainly to people who are teaching energy at secondary level, that's quite a big deal. So what's with the box? Well, what I use the box for is you basically will stick your student's head in the box. And the box is completely dark. And what I have is, I have some words or I have images which are actually written on the inside of the box that the students can't see. And part of the reason I'm doing that, particularly for the younger ones, is showing that in the absence of light, we can't see. Nothing's coming from our eyes. We need the light. But at the back of the box, I actually have a little flap and a little hole. So when my student is actually looking at something in the box, what I can do, I can open that hole at the back and I can shine a torch through that. And suddenly the student will be able to see the images in front of them. Now, the key thing about this is the fact that there's no way that they can see this from this object here emitting light. The light is coming from the back of the box. So the only reason why we can see it is this idea that it has been reflected, or I would tend to use the word bouncing off. It would bounce off the object here and then goes into the eye. So fundamentally, that's what we can do with just a few boxes, a table tennis ball, a couple of lights, and a plant. But could you grow a plant under green light? Well, thinking about green light, what's actually happening is the white light is coming along, it's hitting it. All of that light is being absorbed apart from the green, and the green is being reflected. So if I try to grow a plant under green light, effectively it will not actually absorb any of that light because it will all be reflected, and hence photosynthesis can't take place, and hence you cannot grow a plant under green light. Thank you very much.